All right. Now let's start answering this. Okay. Okay. So this is a question that is given to you. So this is the profile of a wave. Profile of a wave. All right. This 1, 2, 3. All these represent light waves that are coming from the top. That means you have a ripple tank. All right, in that position, and the light ray is coming on top, and the water waves, or the ripples are going like that. So you are looking from the side view. First, you have to get that orientation correct. So you are looking from the side view. So this is the side view of the wave, all right? And the light is coming from the top. This is the base of the ripple tank, okay, which is transparent. So because it's transparent, light is able to penetrate, and this would be your manila card, which is acting as the screen. The manila card, which is acting as the screen, which I've given to you all before. Okay, this is basically how we do experiments based on water waves. Okay, so the examiner has given you, or the question is given that this point is a bright point, that's a dark point, that's a bright point, that's a dark point. So how are these bright, dark, okay, bands, okay, or spots on the, or lines? It will actually form a line, but here you can take it, since you're looking at the cross section, you can take it as spots. How these bright spots and dark spots and bright spots and dark spots are formed. All right, that is all the question. So let us go to the first part of the question. The first part of the question is, what type of wave is this water wave? This is a water wave. What type of wave is this? When they ask you what type of wave is this, there are many categories of wave classification which I've given to you previously. So it is how well you've understood what I've taught you about the wave. One category of classification says progressive, stationary. That means waves can be classified into progressive wave and stationary wave. Another classification is electromagnetic, mechanical. That means you can classify the waves into one group of mechanical waves, another group of electromagnetic waves. The third classification will be longitudinal and transverse wave. So you now got to figure out among these three classifications which applies to this question. When a wave profile is given to you, you got to pay attention to the information and data that is given. A wave profile has been given to you. Therefore, based on this wave profile, your classification should be either it is transverse wave or longitudinal wave. It has to be that. So that is what the examiner is asking you. And you don't go and pick electromagnetic and mechanical or progressive or stationary, all right? Okay, so based on this, you have to decide. So what decides whether it's transverse? What decides whether it is longitudinal? You have to look into the direction of propagation. You have to look into the direction of oscillation of the particles of the medium. Here the medium is water. So the oscillation will be oscillation of the water molecules, all right? So first, let's get the direction of propagation. The direction of propagation will be this. So this is how the wave is moving. So assuming the wave moves from left to right, therefore that will be the direction of propagation. So this is the direction of propagation. Let me lengthen that a bit. Okay, that's the direction of propagation. So I'm going to label that. So I'm going to erase this part because I need the space to label. So this is going to be the direction of propagation. Direction of propagation. Look at the analysis. Learn how to analyze things and then use your creative thinking at the same time. Now I need to know the direction of oscillation. So as the wave moves, what is happening to this water molecule? Look at the water molecule here. Look at the water molecule here, look at the water molecule here, look at the water molecule here. And then this water molecule after that will be going up here. All right? Okay? That means if I look at my finger, that means if I draw, another wave will come like this. Follow my finger. So right now, when they took the photograph, they snapped the photograph, the water molecule is here. Next moment, the water molecule will be going up and then reach the top and then it will be coming down. So in other words, our prediction is the direction of oscillation will be this. That will be the direction of oscillation. So that's the direction of oscillation. So since this is the direction of oscillation or vibration, either one, so you can see the orientation is they are 90 degrees to each other. Therefore, the verdict is transverse wave. Now, I do not want just the answer or transverse wave and all that. You see, the question can also be asked where they can ask you to, okay, indicate the direction of propagation. You as a student must be able to indicate the direction of oscillation. You as a student must be able to indicate. So do you have these skills? That is why you shouldn't be just answering transverse wave without knowing how to design and all that. Okay, all right. So now what you do, take down all these directions in the diagram and then put the answer as transverse wave. Okay, now let's continue. The next part of the question is, on the diagram above, complete the light rays that pass through one of the crests. So one of the crests to show how a bright region is produced on the screen. So the question has already told you that it's a bright region. So if this is the bright region is here. Therefore, these are the light rays that are involved, which the examiner wants. Okay, it cannot be this. These light rays will give you dark. So the examiner has helped you by stating the word bright. Okay, now, anyway, you should know in this wave profile, the highest point, the maximum point on a wave is called the crest. So these are all, look at my finger, these are points of crest. All right, points of crest, whereas these are points of throw. So even the examiner never said bright, but he also gave you another clue. He said light rays that falls on the crest, that falls on the crest. So you should know where the crest is. So you have one or two to pick from. So I'm going to pick the middle one. You can choose either one. So I'm going to pick the middle one. Okay, the concept. What's the concept here? The concept here is the crest. This crest, okay, behaves as a convex lens. This part, look at this part, look at this curvature, look at this curvature. This curvature behaves as a convex lens. So I'm going to, later on the next chapter of light, you'll be learning about the convex lens. So I'm going to do this like that. You can see it's actually a lens. All right, you can see the lens there. It's actually behaving like a convex lens. So what does convex lens do? A convex lens, they cause what we call focusing. They cause converging of light rays. So the light rays here will converge, will focus. Converge means all the light rays will be brought to one point. So the examiner has indicated the point for you to help you. So these two light rays, upon passing the water rays, will come here. So all you have to do is you have to draw that. So from here, we draw a light ray that keeps here. And then you draw a light ray that keeps here. Okay? All right. Let me redraw that. It just has went off course for a while. Okay, let me realign that. Okay, so that will give you the light ray there. That will be okay. This will give you same thing just like this. You will have rulers, so use the rulers and you draw according to what you have got. Okay, all right. Okay, and all light rays must be indicated with an arrow. Now, this length which I indicated to you, all right, you can indicate that for your, in the exam, of course, you don't do that, but you are learning now. You can draw that and we can put it as behaves as a convex lens. Okay, the crest behaves as a convex lens, so the concept I've already given it to you. So you know, and then complete the ray diagram. This is called the ray diagram, and that is how it becomes bright. Okay, bright. Okay, all right. So, all right, let's continue now. So now you are required to mark one distance which is equal to the wavelength of the water wave, and you're supposed to label that with the symbol lambda. All right. So this is what you have. So what you need to do is, in all you should know, you reflect back on your knowledge. You should know lambda is the distance between one crest to the next or consecutive crest. Okay, so distance between two consecutive crests or distance between two consecutive throw. So identify that. So although this is written as bright, so this bright region is actually the representation of the point of crest. This will be the representation of the point of throw. Of course, must take the center point. This is a crest. Okay, so that's your crest. crest, that is also a throw. So according to our definition, okay, distance from one crest. So you can take the center point here to the next crest. You can take that. That will be equivalent to lambda. So you can label that. Or alternatively, so I'm going to alternatively you can take throw. Throw. I want both to be indicated for your learning purpose. Indicate both, but the exam only one. Only one should be indicated. That is also your lambda. That is also your lambda. Throw to throw is also your lambda. So you either can take throw to throw or you can take crest to crest. Okay, that's your lambda. So now indicate that in your diagram. Okay, indicate that in your diagram, all of you. Now we come to the final part. In the final part, you are asked this question. The question is, when the frequency of the water wave is increased, what happens to the wavelength of the water wave? Follow me. So the correct way to think and answer this question is you got to ask, in order for me to answer the question, what happens to the wavelength of the water waves and the frequency is increased? What do I need? What's the concept behind it? Okay, this is something like a relationship. To get this relationship, I need a form of a formula. I need an expression that relates frequency to lambda. So if you were to look back at your knowledge, you'll find that the relationship that relates them is V equals to F lambda. So the examiner is asking what happens to the wavelength. So make your wavelength as a subject. That's what I mean by this is your complete idea. This is how you should pen it down. So they are asking you for the relationship between the wavelength and the frequency. So what happens when the frequency goes up? Very clearly you can see the relationship is inversely proportional. Inversely proportional is the frequency, is the relationship. But this inversely proportional will only hold true with one condition. That's the meaning of incomplete idea. Some of you will never know this condition. Provided your speed of the wave remains constant. This must remain constant. So in this question, does the speed remain constant? Does this quantity remain constant? If this quantity does not remain constant, then the relationship cannot be inversely proportional. That means, let's say this is changing. This is also increasing. And then you cannot ascertain what's the relationship. So you need to question that first. You shouldn't assume. All right? You shouldn't assume, you should question. This is where you should know the speed of water wave depends on the medium. Depends on the medium. More accurately depends on the density of the medium and also other factors such as temperature of the medium. So as long as, density of the medium, in the case of water, it also depends on the depth of the water. In this case, is water waves. So it depends on the density of the medium. That means it depends on the density of water. It depends on the depth of the water. It depends on these two, the speed. So for example, you're using fresh water and then you replace with seawater. It's different. The speed is not the same because the density is altered. Or you're using the water level is 4 centimeters, then you add more water and make it 5 centimeters. The speed is different. So in this case, none of this alteration was done, which means the density remains the same, the depth remains the same, therefore your speed is indeed constant.